People in the open source AI space are starting to hit a limit with regular chatbots. The excitement of an AI simply answering questions is starting to fade. Now, users want agents that can actually do things, run commands, manage complicated workflows, and finish the tasks they start. This split screen introduces the two main open source contenders trying to solve that problem: OpenClaw on the left and Hermes Agent on the right. At a basic level, these systems are built very differently. One is focused on organizing communication across a network. The other is focused on building a standalone environment where an AI agent can learn and improve over time. OpenClaw is built around connection. Its goal is to link one AI system to every channel, device, and workflow inside a user's existing setup. As these comparison panels show, Hermes takes a different approach. Instead of focusing on connecting everything, Hermes focuses on continuity. It is designed to create a worker that gets better the longer it runs. At this point, the biggest challenge is no longer just how smart the AI model is. The real challenge is the system around the AI, the structure that helps it remember, recover from mistakes, and keep working over long periods of time. This network diagram shows OpenClaw's command center approach. A central gateway sits in the middle and routes messages from outside platforms like Discord, WhatsApp, and Slack. That gateway becomes the main control point, allowing users to manage persistent teams of agents across all those connected channels at the same time. Hermes moves away from that router-style model. This interface display shows its main focus: a dedicated personal workspace built around a learning loop and the promise of an agent that grows with you. Hermes runs directly on your own hardware. Instead of trying to connect to every chat app, it focuses on executing complex commands and turning repeated work into stronger automated workflows. When it comes to handling complex tasks, the tools separate even more. OpenClaw relies on coordination between groups of agents that can stay active across long sessions. This flowchart compares that network-style setup with the Hermes approach, which works more like a top-down tree. In Hermes, a main agent can quickly create smaller sub-agents to work on separate parts of a task at the same time. If a project requires coordinating communication across multiple channels, a gateway-style tool like OpenClaw makes sense. But if the goal is to turn a multi-step process into an automated workflow, a focused runtime like Hermes is the better fit. The biggest risk for an agent running for days or weeks at a time is not always bad logic. Often, the real problem is too much context. When the AI remembers too much irrelevant information, that noisy memory can weaken its decision-making. This graphic shows how each system handles that problem. On the left, OpenClaw uses a rich, persistent memory system. It can save detailed daily notes, but over time, too much saved information can overwhelm the AI. On the right, Hermes uses a cleaner, more searchable memory setup. This funnel diagram shows Hermes' bounded notebook system. Files like memory.md and user.md have character limits, which forces the AI to keep its notes focused. Only the most important information makes it into the system prompt. When Hermes needs older information, it can search for it instead of keeping everything loaded at once. For example, if the agent needs a detail from a project 3 weeks ago, it can search its local database and pull that information back in without cluttering the current task window. This cleaner memory system helps create a compounding work loop. This diagram shows how Hermes moves from completing a task to creating reusable skills. When Hermes solves a difficult problem, it can write down the workflow in a markdown document, like the skill file shown here. By saving the triggers and instructions, Hermes does not have to struggle through the same process again later. An agent without this kind of procedural memory is like a worker who forgets everything after every meeting. But an agent that writes its own playbooks can become more valuable over time. So why is Hermes gaining so much community momentum right now? A big part of the answer is its focused development cycle. This feature stack from the recent Tenacity release highlights important additions like durable command execution, checkpoints v2, the goal primitive, and auto-resume. In simpler terms, Hermes is building solutions for the exact moments when AI agents usually fail, when they drift off topic, make things up, get stuck, or silently stop working in the middle of a task. This chart compares those open-source features with the reliability standards being built by larger enterprise systems like Claude. Hermes isolated subagents and lifecycle hooks follow the same general recovery patterns that are becoming important across the AI industry. The bigger lesson is clear: raw intelligence is not enough by itself. Autonomous AI workers need guardrails, recovery points, and systems that help them stay on track. Hermes is gaining goodwill because it treats failure recovery as a core part of the product, instead of relying only on fragile prompting tricks to keep the agent focused. Of course, neither tool is perfect. This table compares OpenClaw and Hermes across setup, flexibility, logic, and learning. OpenClaw offers faster setup and broad flexibility, but it depends more on static marketplace skills. Hermes takes longer to set up, but it can generate dynamic skills based on its own behavior and repeated workflows. In the end, the choice comes down to what kind of problem you are trying to solve. OpenClaw's biggest risk is noise. Too much context and too many connected agents can make the system harder to control. Hermes' biggest risk is being too narrow. It can handle familiar tasks quickly, but it may struggle more with open-ended team coordination. OpenClaw paves the roads, while Hermes trains the driver. Reliable automation depends on agents that have the systems needed to finish what they start. The industry is now moving toward memory, recovery, and procedural skill creation, not just broad connectivity. The most effective agents will not just connect to more tools, they will remember what worked, reuse it, and improve over time.